Hi learners and welcome to another video, and today we're going to be looking at similar triangles. What are similar triangles? Similar triangles are two triangles which are not necessarily the same size. We'll have one big triangle and one small triangle, but in these two triangles they will be equiangular, which means that all the angles in one triangle will equal to all the angles in the other triangle. Now, to prove that two triangles are similar, we just need to show that two angles in one triangle equals to two angles in the other triangle. So if we can show that x and x are equal with a statement and a reason, and y and y are equal, and if we can give a reason for that, then these two triangles, A over P is equal to B over Q, B over Q is equal to C over R. We can prove that they're all in the same ratio, then the two triangles are similar to one another. Now, the symbol for similarity, let's write that down very quickly. So if I want to write this down, triangle, let's write it down. So that's angle A, so that must be, that's side A, so that must be angle A. That's side B, so that's angle B. That's side C, the whole side here, AB is, the symbol is C, so that will be angle C. We give it Z here. And here that's angle, this is angle R. And we have P and Q, that is Q. So if I was to write these two triangles in the correct order, it will be, let's go X, Y, Z. You have to write it in the way that the angles are named. So let's go X, Y, Z. So it will be triangle A, B, C is similar to triangle, let's go X, Y, Z. So X, Y, Z will be P, Q, R. And you remember, if two triangles are similar, their sides are in proportion. So one very important thing for you to take note of here is that we say, how do we write the sides in proportion? So very simple technique. See these first two letters AB, and those first two letters PQ. We can write it like this: A, B over PQ will equals to, see the second two letters here, BC and QR. So it will be BC over QR, which will equals to first and last letters of how I name the triangle, AC all over PR. So once again, if two triangles are similar, the sides are in proportion. How do we prove two triangles are similar? We prove that they are equiangular. And what do we need to do? All we need to do is just prove that two angles in one triangle equal to two angles in the other triangle. What's another way to prove that two triangles are similar? Well, we can prove that their sides are in proportion. So if we can show that AB over PQ equals to BC over QR equals to AC over PR, then we can prove that these two triangles, ABC, will be similar to PQR. And finally, if we can prove that two sides are in proportion and we have an included angle which are equal to one another, the included angles are equal, and they have two sides in proportion, then the two triangles will be similar. But case 1, equiangular and sides in proportion, is what we'll be focusing on in most of the examples. So let's look at an example. Before we look at any examples, remember what I always tell you in all my videos. Number 1, make sure that you read and have a good understanding of the theory. Number 2, make sure that you write down a summary and read over your summary and practice with work. Start off practicing with worked examples. So after you are ready to do that, then we can look at some examples. So if you're going to be looking now at this first example, so what I would advise you to do is pause the video here, try and answer this question, and then come back and see whether your solution matches mine. Alright, so now that you are back after answering the question, let's see whether your answer is correct. So here we have, it says study the diagram below, and you are given that triangle ABC is similar to triangle DEF. Now this is the sign for similar triangles. So we are now told that triangle ABC is similar to triangle DEF. So we are already given that the two triangles are similar, therefore their sides are in proportion. So the first thing that I need to write down is their sides in proportion. So just as I told you before, the first two letters is AB, so we need AB over the first two letters here is DE. DE will equals to the next two letters is BC and EF, so it will be BC over EF equals to first and last letters is AC there, and the first and last letters there is DF. And that is because they told me that two triangles are similar. Triangle ABC is similar to triangle DEF. Now all I need to do is to fill in the information that was given to me. The length of AB is 6. DE is 4. BC is 18. And EF is 12. AC is 12, and DF is what I need to find. DF. So let's look at that. So if I look at this very carefully, 6 over 4 equals to 18 over 12 equals to 12 over DF. So I need to find DF. So I will have to write that down first. 12 over DF. I can choose any one of these ratios because they are the same. 6 over 12 is equivalent to 18. 6 over 4 rather is equivalent to 18 over 12. So let's choose the simpler ratio, 6 over 4. And now we're going to solve for DF. In order for us to solve for DF, we're going to cross multiply. So to cross multiply, it will be DF times 6 equals to 4 times 12. Therefore, DF is equal to 4 times 12 divided by 6. And let's put that in our calculator. 4 times 12 divided by 6 equals to, the answer is 8. So let's look at that once more. There's no units given, so therefore we'll just write 8 units. So once again, a quick recap. If two triangles are similar, their sides are in proportion, and we choose our unknown and any one complete ratio, cross multiply and solve for the unknown. Let's look at the next example. In the next example, 8.2, we are once again given calculate the length of AB if triangle ABC is similar to triangle EDF. Now here's a good time for you to actually pause the video, try to answer this question, and come back, answer it, and check the answers out after that. So you can pause the video now. Okay, so let's check the answer out. Okay, so I hope that you've done it, and let's see whether you're on the right track. So if we have to quickly review what we've been taught already, it says calculate the length of AB if triangle ABC is similar to triangle EDF. So learners, we are given that the triangles are similar, therefore their sides are in proportion. So now we look at the first two letters, AB and ED. So we'll say AB over ED equals to the second two letters is BC and DF. So it will be BC over DF equals to the first and last, AC over EF And that is because the two triangles are similar. Triangle ABC is similar to triangle EDF. Now let's fill in all the information that we have on our diagram. So BC is 15. So let's look at it very closely. So AB, we don't have a measurement for AB. They want us to actually find AB. ED is 6. So we'll write that down. Equals to BC is 15. And DF is 10. So now we're going to look at solving. Now AC and EF don't have any measurements, so I'm not going to write anything down for AC. Okay, let's write down AC and let's write down EF is 4. Alright, so now if I look at this very carefully, they want me to solve for AB, therefore I have to use that ratio. And I have a complete ratio here, which is 15 over 10. So that's the two that I'm going to use. And I can't use AC or 4 because I have AC, which is unknown. So now I'm going to cross multiply. AB times 10. AB times 10 equals to 15 times 6. AB equals to 15 times 6 divided by 10. Let's put that in our calculator. Times 6 divided by 10, and that's equal to 9. So my solution there will be 9, and the units given is centimeters. Answer is AB is 9 centimeters. They only asked us for AB, so that is complete. AB is equal to 9 centimeters. Quick recap. Once again, if two triangles are similar, their sides are in proportion. And looking at this, once again, we will fill in all the information that's given, use a complete ratio, and obviously the ratio where we have our unknown which we need to solve for, cross multiply and solve. That is, let's look at the last question. Now in this particular question, once again, it's telling us that in the figure VW is 12 centimeters, VW is equal to 12 centimeters, and XY is equal to 4 centimeters, UV is equal to 8 centimeters, and they tell us XY is parallel to UV. Prove that triangle XYW is similar to triangle UVW. Now, if you haven't answered this question as yet, I suggest you pause the video here and answer the question. Come back to it in a few minutes. Okay, so if you've answered it, let's go and do the solution. So for 6.2.1, how do we prove two triangles are similar to one another? In order to prove two triangles are similar, we can either prove that they are equiangular, or we can prove that their sides are in proportion, or we can prove two sides in proportion and an included angle equaling to triangles. But let's look at the first instance here. Can we prove that they are equiangular? They gave us that these two triangles here, so let's look at the two triangles that we need to prove first. X, Y, W. So there's X, Y, W. So one of the things that you can do to make it a little bit easier for you is you can highlight the given triangles. Okay, so X, Y, W. So that one is the pink triangle. And let's look at the other one, which is UVW. So UVW. So I'll try not to go over that so that we can distinguish between the two triangles. Right. So now that we have both of those triangles, let's just quickly go back to my pen. Alright, so that's done. Now they told me that these two triangles, I must prove that they are similar. and xy is parallel to uv. So xy is parallel to uv. So if you watch the previous video, lines, angles and triangles, you'll know that when they give us parallel lines, they most likely are testing fun angles, FUN, corresponding co-interior and alternate angles. So let's look at it. Firstly, we have a common angle which is V. That's number one. Common angles are equal to one another. Number two, we look very carefully. So that's it. So we have XYW and we have UVW. So W and W. So that's a common angle. So I already have one angle. I have one statement. I just need one more statement. So right, let's look at the relationship between X and U. If I look at X and U, you are able to see the F shape here. And the F shape means that these two angles here are corresponding angles. Similarly, I could prove that y is equal to v. And as you can see here, y1 will equal to v. That's also corresponding angles. So now that I have all my statements, I can now write my proof down. I always start off my proof by saying in triangle X, Y, W and triangle U, V, W, my first statement will be that, if I look at it very carefully, this is W, U, V, W, so W is common. So W is common in both triangles, and my next statement that I will write down is X equals to U, that is X1 equals to angle U, so angle W is common, and this will be my reason with the corresponding angles. And let's write down the pair of parallel lines, X, Y parallel to U, V. Now this is already proven because I only need to prove that two angles in one triangle equal to two angles in another triangle. But because I have the third statement, I will write it down. And therefore I will write y1 equals to v. And that's also corresponding angles, and that is because xy is parallel to u, v. And there you go, learners. Therefore, triangle X, Y, W is similar to triangle U, V, W, and my reason would be angle, angle, angle. And that's because the two triangles are equal angle. So once again, let's look at this. So we highlighted the two triangles, and once highlighting the two triangles, we were able to see which angles are equal to one another. And remember that when we write in the statement, we must have a reason. So the statement and the reason is very, very important. Calculate the length of YW. Calculate the length of YW. So they want you to find the length of YW. So let's look at that very, very carefully. What information do I have? Now the length of YW. So what did we learn thus far? Well, we learned that if two triangles are similar, then their sides are in proportion. So what does this mean? It means that X, Y, remember the first two letters there, over the first two letters, U, V, is going to equal to, the second two letters there is Y, W, over the second two letters there is V, W, and the first and last letters there is X, W, all over the first and third letter, or first and last letter is U, W. And that is because the two triangles are similar, and I just proved it. Triangle X, Y, W is similar to triangle UVW. Now fill in all the information that you have. You were given that VW is equal to 12, XY is equal to 4, and you were given that UV is equal to 8. So let's fill in all that information. So once again, I'm given that XY is 4, so I will put in 4 over UV. UV I'm given is equal to 8, so I put in XY, UV is equal to 8. YW is what I need to find, and VW is 12, and there's it right here. So let's put that in. So VW is equal to 12. XW and UW, I haven't been given measurements for that. So what do I do from here? Well, I just cross multiply as I taught you. YW times 8. Cross multiply. It's going to be equal to 4 times 12. Therefore, YW equals to 4 times 12 all over 8. 4 times 12 all over 8 will give us 4 times 12 all over 8 equals 6. So now we can conclude that YW is 6. Learners, let's look at this question one more time. Remember that if two triangles are similar, the sides are in proportion. And once again, fill in your unknown values by looking at the technique that I showed you. Remember that the way the triangle is named is the way the angles are equal to each other in both of the triangles. After we substitute our given values, cross multiply, solve for the unknown by cross multiplication. Right? Some of these numbers are quite easy and we do not need to use a calculator. However, I have used a calculator just to make sure that everything is in order. Learners, this is Similar Triangles. If you haven't subscribed to my YouTube channel, JL Maths, then please do subscribe, share, and like the videos, and don't forget to hit the bell notifications so you can check out any new videos that come up. Also don't forget to check out my videos on jlmaths.com, and I'll catch you in the next video.